Preparing for a software engineering at MUFG interview? You've reached Candy Mentor, and this video is for you. We'll walk through 20 key questions you're likely to face. For each question you'll see a sample answer followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. How would you design a reliable payment transaction service for a bank? I would model a payment as an explicit state machine. Initiated, authorized, submitted, settled, failed, or reversed. Each request receives an idempotency key, preventing duplicate transfers during retries. A transactional database records state and an immutable audit event. External bank integrations use timeouts, durable queues, reconciliation jobs, and compensating actions rather than unsafe distributed transactions. I would add encryption, role-based access, monitoring, and alerting. Correctness and recoverability matter more than maximizing raw throughput. While answering, cover transaction state transitions, idempotency, database consistency, retries, audit trails, authorization, encryption, failure recovery, observability, and regulatory requirements such as traceability and data retention. Question 2. What object-oriented design principles do you use when building enterprise Java services? I use objects to protect invariants and separate responsibilities, not simply to create many classes. For example, a payment service can depend on a payment repository interface while a concrete database adapter supplies persistence. That supports dependency inversion and unit testing. I prefer composition when behavior varies, because it avoids brittle inheritance trees. Interfaces should represent stable capabilities, and classes should expose minimal state. I also challenge every abstraction, since unnecessary indirection increases maintenance cost. Make sure to cover encapsulation, abstraction, polymorphism, composition over inheritance, single responsibility, dependency inversion, testability, interface design, and avoiding unnecessary patterns or overly complex class hierarchies. Question 3. How would you prevent duplicate processing in a money transfer API? I would require a client-generated idempotency key scoped to the account or operation type. The service stores that key, request fingerprint, final response, and transaction result under a unique constraint. Concurrent requests serialize through the constraint or transaction, so only one transfer executes. Retries return the stored response, while mismatched payloads produce an error. If a downstream provider times out, I mark the operation pending and reconcile asynchronously rather than submitting another transfer blindly. In your answer, talk about idempotency keys, unique constraints, transactional boundaries, request replay behavior, concurrent requests, response persistence, retries, and reconciliation when downstream systems provide uncertain outcomes. Question 4. Explain how you would secure a REST API used by banking applications. I would enforce TLS everywhere and validate short-lived, signed access tokens, including issuer, audience, expiry, and scopes. Authorization must be checked server-side at both endpoint and resource level. Authentication alone is insufficient. Inputs need schema validation, size limits, and parameterized database access. I would apply rate limits, rotate secrets through a vault, avoid sensitive data in logs, and emit tamper-resistant audit events. Security testing would include dependency scanning, penetration tests, and threat modeling. Be sure to mention TLS, OAuth or token validation, authentication, authorization, input validation, rate limiting, secret management, audit logging, replay protection, secure errors, and protection against common API attacks. Question 5. When would you choose a monolith instead of microservices for a financial system? I would choose a modular monolith when the domain is still changing, the team is small, or transactions cross many business capabilities. It offers simpler deployment, local calls, consistent transactions, and easier debugging. I would enforce internal boundaries through modules, interfaces, and ownership so extraction remains possible later. Microservices become valuable when independent scaling, release cadence, or fault isolation justifies their operational cost. In banking, distributed complexity should be introduced deliberately, not because it sounds modern. Focus on team size, domain boundaries, deployment independence, transaction requirements, operational maturity, latency, testing complexity, failure isolation, organizational costs, and a migration path that avoids premature distribution. Question 6. How do database indexes improve performance, and what problems can they create? An index is an additional access structure that lets the database find rows without scanning the entire table. I would inspect the query plan and index columns used for selective filters, joins, and ordering. Composite indexes should follow common predicates and their leftmost usage patterns. Indexes improve reads but consume storage and slow inserts, updates, and deletes. I would add only measured indexes, refresh statistics, and verify improvement with representative production-like workloads. Discuss B-tree or appropriate index structures, selectivity, query plans, composite index ordering, write overhead, storage, stale statistics, covering indexes, and measuring changes with execution plans. Question 7. Describe a strategy for handling database concurrency in account transfers. For a transfer, I would update both accounts within one database transaction and enforce a non-negative balance invariant. To prevent lost updates, I could lock the relevant rows or use optimistic version columns. With locks, I would acquire accounts in deterministic order to reduce deadlocks and retry safely when one occurs. The isolation level should match business needs rather than default blindly. I would test concurrent withdrawals, failures, retries, and rollback behavior using load and race condition tests. Cover isolation levels, row locking, optimistic versus pessimistic concurrency, deadlock handling, atomic balance updates, transaction ordering, consistency rules, and testing concurrent transfers under realistic load. Question 8. How would you design an event-driven integration between MUFG services and external financial systems? I would publish durable domain events through a broker after committing the business change, using an outbox table to avoid database message inconsistency. Consumers would be idempotent, store processed event identifiers, and tolerate at least once delivery. Schemas need versioning and backward compatibility. Failed messages go through bounded retries and a dead letter queue with operational ownership. For external systems, reconciliation compares acknowledgements and settlement records. Encryption, access controls, correlation IDs, and lag metrics complete the design. In your answer, include durable messaging, event schemas, delivery guarantees, idempotent consumers, ordering, dead letter queues, retries, versioning, encryption, reconciliation, and monitoring of delayed or failed events. Question 9. What is your approach to testing a high-risk banking application? I start with fast unit tests for business rules, especially fees, limits, and state transitions. Integration tests validate real database behavior, transactions, migrations, and message handling. Contract tests protect interfaces between services, while a smaller end-to-end suite verifies critical customer journeys. I also test authorization failures, timeouts, duplicate requests, recovery, performance, and security vulnerabilities. Test data must be synthetic or masked. In regulated systems, traceable requirements and repeatable evidence are as important as coverage percentages. Make sure to cover unit, integration, contract, end-to-end, performance, security, mutation or property-based testing, test data protection, regression coverage, and validating failure and recovery paths. Question 10. How would you investigate a production latency spike in a transaction service? I would first confirm scope using latency percentiles, error rates, affected endpoints, regions, and transaction types. Distributed traces can reveal whether time is spent in application code, the database, or an external dependency. I would correlate the spike with deployments, traffic, resource saturation, query plan changes, and queue lag. Mitigation might include rollback, throttling, or temporarily disabling a non-critical feature. After recovery, I would document root cause, add targeted alerts, and verify the fix with load testing. Discuss defining the symptom, dashboards, distributed tracing, logs, recent changes, saturation signals, database plans, dependency health, controlled mitigation, rollback, root cause analysis, and preventing recurrence. Question 11. What does good observability look like for a financial transaction platform? Good observability combines technical and business signals. I would track request rate, latency percentiles, errors, saturation, queue depth, database health, and dependency availability, alongside payment states, settlement delays, and reconciliation mismatches. Structured logs and distributed traces should share a correlation ID, but never expose account secrets or unnecessary personal data. Alerts must identify actionable symptoms with sensible thresholds and ownership. Immutable audit records serve compliance, while operational telemetry supports diagnosis and capacity planning. Focus on meaningful metrics, structured logs, distributed traces, correlation identifiers, business-level indicators, alert thresholds, privacy controls, dashboards, auditability, and distinguishing symptoms from underlying causes. Question 12. How do you handle backward compatibility when changing a public API? I first identify consumers through ownership records, traffic telemetry, and contract tests. I prefer additive changes, optional response fields, new endpoints, or new versions, while preserving existing semantics. Consumers should tolerate unknown fields, and breaking changes require a documented migration period. I would announce timelines, provide examples, monitor old version usage, and test both contracts continuously. Removal occurs only after usage reaches 0 or owners approve. Compatibility is a product promise, not merely a code review concern. Be sure to mention consumer discovery, additive changes, semantic versioning, tolerant readers, deprecation periods, contract testing, migration communication, telemetry, and safely removing obsolete fields or endpoints. Question 13. How would you implement a secure continuous delivery pipeline for Java services? My pipeline builds an immutable artifact once, runs formatting, unit, integration, security, dependency, and container checks, then promotes that same artifact across environments. Secrets come from a managed vault, never source control or build logs. Infrastructure and configuration are versioned, and deployment identities receive least privilege. I would use canary or blue-green releases, health checks, automated rollback, and approval gates for high-risk changes. Every promotion records who, what, when, and validation results. Discuss code review, automated tests, dependency and container scanning, secret handling, artifact immutability, environment promotion, approvals, rollback, infrastructure as code, audit trails, and least privilege pipeline access. Question 14. Explain how garbage collection affects a Java application's performance. Garbage collection reclaims unreachable objects, but allocation pressure can create pauses or CPU overhead. I would inspect allocation rates, heap occupancy, pause percentiles, promotion behavior, and GC logs before changing settings. Memory leaks often mean unintended references, not failed collection. Heap size and collector choice should reflect latency and throughput goals. Larger heaps are not automatically better. I would reduce unnecessary allocations, investigate retention with a profiler, and validate tuning under production-like traffic. In your answer, cover heap generations or regions, allocation rates, pause times, throughput, memory leaks, GC logs, heap sizing, collector selection, and tuning based on measurements rather than assumptions. Question 15. How would you design authentication and authorization for internal banking services? Each service should have a verifiable workload identity, using mutual TLS or short-lived signed tokens rather than shared credentials. Authorization combines roles with resource attributes such as account ownership, region, or transaction limit. Checks occur at the service boundary and resource level, with least privilege and separation of duties for sensitive actions. Keys rotate automatically, access is audited, and emergency privileges are time-bound and approved. Network location alone must never be treated as authorization. Cover service identity, mutual TLS or signed tokens, RBAC and ABAC, least privilege, token lifetime, key rotation, resource level checks, separation of duties, audit events, and emergency access controls. Question 16. What is your approach to solving a coding problem involving transaction records? I begin by clarifying record volume, ordering, duplicate semantics, timestamp format, and whether data fits memory. For example, finding the first repeated transaction can use a hash set for expected O(n) time and O(n) space. If memory is constrained, sorting may reduce auxiliary space but costs O(n) log n time and changes ordering. I would handle empty input, null records, duplicate identifiers, and numeric overflow explicitly. Then I code, test examples, and explain complexity. Make sure to cover clarifying assumptions, data structures, complexity analysis, edge cases, streaming or sorting choices, overflow, duplicate records, and explaining trade-offs clearly before coding. Question 17. How would you improve a legacy banking application without interrupting critical operations? I would first map dependencies and capture current behavior with characterization, integration, and production traffic tests. Then I would isolate one bounded capability behind a stable interface and migrate it incrementally using a strangler approach. Feature flags, canary releases, dashboards, and rollback procedures limit blast radius. I would preserve data contracts and run old and new paths in parallel where practical. Prioritization should target operational risk and customer value, not modernization for its own sake. Discuss characterization tests, dependency mapping, strangler patterns, incremental releases, feature flags, observability, backward compatibility, risk-based prioritization, rollback plans, and stakeholder communication. Question 18. Tell me about a time you disagreed with a technical decision. On one project, a teammate proposed synchronous calls between several services for a settlement workflow. I was concerned about cascading timeouts and difficult recovery, so I documented failure scenarios and compared an asynchronous design. We discussed the trade-offs with the team, measured expected latency, and chose synchronous processing for the user-facing authorization while moving settlement to a durable queue. I supported the decision fully, added timeout and reconciliation safeguards, and learned to separate technical disagreement from personal preference. Focus on the situation, evidence gathered, respectful communication, alternatives, risk assessment, decision ownership, measurable outcome, and what you learned about collaboration and adapting after disagreement. Question 19. How do you prioritize reliability, security, and delivery speed when deadlines compete? I classify the risk first. A deadline may justify reducing scope or launching a non-critical feature later, but it should not justify bypassing authentication, auditability, data protection, or transaction correctness. I would propose a phased release with explicit controls, measurable reliability targets, and a rollback plan. If risk remains unacceptable, I escalate with evidence and alternatives rather than silently accepting it. Speed is sustainable only when the team understands and manages the consequences. In your answer, discuss risk classification, non-negotiable controls, threat modeling, phased scope, transparent trade-offs, stakeholder escalation, measurable service objectives, and avoiding shortcuts that create hidden operational debt. Question 20. Why do you want to work as a software engineer at MUFG? I want to work at MUFG because financial software combines meaningful customer impact with demanding engineering standards. Reliable payments, secure data, and resilient platforms require disciplined design, testing, and operational ownership. I am motivated by the opportunity to contribute to modernization while respecting the controls that protect customers and the institution. My strengths in backend development, databases, and troubleshooting would help me deliver dependable services. I also value MUFG's global environment and the chance to keep learning. Be sure to connect motivation to financial technology, large-scale reliability, customer trust, global collaboration, learning, responsible engineering, and specific ways your skills can contribute to MUFG's transformation. If you are still with us, congratulations. You are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.